today we've got cloud computing, which is very exciting and a lot of fun and becoming somewhat ubiquitous for a lot of people in computational science and research. So we have three speakers. We have Santosh Bhatt, who'll kick us off and talk about the Oracle Cloud. And then we'll have Paul Yu from Azure talk about the Azure Cloud. And the Oracle Cloud is great. It's like bare metal clusters. And we used both of these resources for the student cluster competition last year. And we're not sure there will be a cloud component for the student cluster competition this year. So cloud computing is important. And then to wrap it all up, Marty Kandes will talk about the JetStream cloud computing environment ecosystem, and that you have access to through our HPC user training allocations. So you'll be able to get on there and actually do some hands-on work. But I wanted to give an overview, and Matthew Mikhailov and John Gee will be giving just a couple minutes on their experiences. Matthew will talk after Paul Yu, and John will talk after Santosh is done. Our first speaker then is Santosh Bhatt. He was one of our mentors for the Student Cluster Competition with the Oracle Company's Cloud. And so we'll let him get started talking about that. And thank you for coming, Santosh. Cindy, is Santosh a co-host?
Yes.
Okay. Great. Thanks, Mary, for that introduction. I will just share my screen. Let me know if you are able to see my screen.
Yes.
Okay, great. So just a very quick introduction about me. I'm a principal enterprise cloud architect, and I love education. So that's why, I work with the higher education customers because that is next to my heart, education piece. So I am with Oracle for last 5 years or so, but before joining Oracle, I was with Intel for almost 18 years, and I worked on to all these Pentium chips. I was in the manufacturing sector there, so I am very, very familiar with all this Pentium 4, 5, 6, all onward. So it is nice. Thanks for the opportunity to talk here. I know I have a very limited time, 30 minutes, so I may not be able to go deep dive into technical, but on some other occasion, I can definitely go deep down into the technology. So, as you know, Oracle Cloud Infrastructure is one of the cloud components, and Oracle entered late into the cloud. But it had its own advantage also, because Oracle looked into whatever the weak point or whatever improvement required from Gen 1 cloud technology, they incorporated it in Gen 2 cloud technology. So Oracle started with now Gen 2, which has pretty much all the services available now into the cloud. Not every application or every workload can move to the cloud right away. So we also have provided a hybrid cloud, which means, some portion of your workload can still stay in on-premise and some can move into the cloud, and they both can, communicate to each other. So that way there is no loss of service. So also we have Oracle Cloud behind your firewall inside your data center. So that hybrid cloud model is also available. We also provide the autonomous services, and what it is basically a self-healing, self-tuning system. Because we realize that all these mundane type of tasks, installation of the database, patching, upgrading, is really a time-consuming and does not add too much value. So what we did, we basically automated those activities in the cloud. So when you provision a database in the cloud, all those things are taken care for you. It's just the click of button and database gets provisioned and starts running. So also we realized that moving your workload to the cloud may sometimes be very time consuming. So we developed some tool also, what we call is a migration tool, in order to help into that effort. Let's keep on moving here. So this is our, like big infrastructure piece of picture, very overwhelming picture here. But we have complete breadth and depth of every services. So it starts with an applications. We also have a data and AI now. A lot of AI and ML type of work is going on. So we have those services also in our local cloud. Database, we have two flavors. One is the regular standard database, which you are familiar with, and another is autonomous database, which basically, self-healing, running system. We have core infrastructure, which is a compute. And in the compute, we have a bare metal virtual memory base, CPUs, GPUs, and HPC. And that's one of the, component was used during this, competition. We did configure the HPC environment and, they start working there. We also support containers, VMware, various, flavor of storage and networking. Also, we are very big on the security because we know, putting your sensitive data in the cloud is not that easy. So we just wanted to make sure that when we design the application, security is the part of that design. We have a lot of monitoring tools within the security portfolio, CloudGuard, web application firewall, DDoS, all those things we manage there. So once you put your data, we really manage those data just to ensure that there are no, data stealing or, okay. Somebody's asking who can see this transcript. Okay, anyhow. Any question? Am I moving too fast?
Santosh?
Yeah.
Santosh, Mary here. Because you're a co-host, you're going to see signs of people entering and questions. We'll take care of all of that.
Oh, okay. Because
we'll answer questions. Yeah, no, we'll answer questions unless we can't, then we'll direct them to you.
Sure. Thanks. And I saw a couple of people wanted to get admitted, so I clicked on the admit button also. So they should all be in this conference then, or in this meeting.
Cindy will take care of that.
Okay.
Just ignore the sign. She's on top of it. Thanks.
Okay. Is there any question? Am I moving too fast? Okay, let me move on. So some of the code, okay, one slide, we missed it. Also for the research community, we have, services exclusively for them. Like we have a data science cloud, big data cloud. Also we have, a lot of, integration cloud. So that way, any of the integration point is not broken. I wanted to make sure that all the integrations piece are intact. So those services are also available. And then go to the next one. Some of the core technology, what we have, and that is what makes the migration of enterprise application much simpler. We have off-box virtualization. So once you provision a VM in the cloud, there are no concept of noisy neighbor there. That VM belong to you, and you are the one who will be working on that. It has complete isolation from any other workload. We have a zero trust approach, so that way no other tenants can see your data or steal your data. So we also have non-blocking networks and RDMA technology, which we are using, and that is what we use into the HPC. Is basically remote data memory access over actually Rocky network. We have a flex infrastructure, which means if based on your workload, if you want to scale up or scale down, that kind of infrastructure is available in our cloud. Also, as I was talking about the migration, because it's very hard sometimes to migrate your on-premise workload to the cloud without like big spending too much time. So for that reason only, we brought a lot of tools which helps in migrating the workload to the cloud. We go to the next one. Also, some of the applications design what we have done, which is the first phase of the migration. Usually it is no re-architecture required, which means no single line of code change. The application will work as is, like it was working on-premise, is in the cloud. And that gives you a flexibility of expanding, temporalizing that, creating more VM workload. All those things are available at that point of time. We have a broad suite of OCI services, as I talked about. Also, a lot of development tools are available in the ecosystem, like Terraform, GitHub. Lot of networking, portfolios are also available there. Okay. And technology we support, like Linux, Windows, all flavor of Linux, we support that. We have a Kafka compatible streaming also available. And again, all those Kubernetes engine, we support that. So it's a complete suite of development tools are available in the cloud. So once your developer community start using it, they will see how easy it is to develop any application in the cloud. We also have a partnership with Azure, where like some of the Azure workload can be shared with the Oracle, and from Oracle workload to Azure. So we have interconnect available, what we call a Express Connect for sharing the workload. Autonomous service, as I talked about, is basically automatic provisioning configuration. The whole idea here is to avoid the human error, by including a lot of stuff inside the engine itself. So, like for example, any security vulnerability patching coming, before even you're knowing, it will automatically be patched for you. So, so that way, there are no issue there. It also have a tuning feature. It eliminates downtime, which means all the upgrade patching is done with zero downtime. So that is why that autonomous services was created there. Lot of autonomous services come in two flavor. One is for just for data warehouse type of workload, and other is for the transaction processing. So OLTP type of work can also be done on that. And then Oracle Autonomous JSON databases are also available. We have complete support for hybrid and multi-cloud strategy. We have public cloud as well as dedicated. We also have now partnered with the VMware, so we provide the VMware solution in the cloud. We have Exadata Cloud at customer, available, and of course Microsoft Azure Interconnect. This is our entire, the cloud presence all around the world. So we have like 31 regions live and running, and the reason why we have so many regions, because of the some compliance and governance reason, we are having some of the data center located into that region. Okay, so we have a commercial, government, and Oracle Cloud and Microsoft Azure. So now let me just little bit drill down into what we call it region in the Oracle Cloud. So region is nothing but a physical data center in that geography. So like for example, Phoenix is one region where we have these data centers. And whenever we talk about data center, most of our data centers have a 3 availability domain, and availability domain is nothing but a physical data center. So in a given region, we have three physical data center, and they all are connected. They are like around maybe 40 to 50 miles apart. And the reason is, we want, if suppose for some reason availability domain went away, or disaster happened, at least you have availability domain 2, where all your data will, fail over, and you can still use your services there. Okay. Then with the region, and each region and the data center has a physical network where servers are, and then all of those physical network is then summed up into the virtual network. Okay, that is how the our OCI is built in, and all these servers what you are seeing, bare metal, VMs, Exadata, load balancer, all of these are off of this virtual network. Also, one thing I wanted to mention, within even each data center, you have something called fault domain. So we have 3 fault domain, and the idea there was that we have provided total redundancy there. So one of each workload when you bring, they will be distributed among different infrastructure within a availability domain. So a lot of redundancy built in just to maintain the high availability in the cloud. I talked about interconnect between Oracle and Microsoft Azure. So we are very big into the security. So protecting data is our top priority, and whenever we are designing the application, the security is part of that design, because we just want to make sure there are no breach of your data happens, no ransomware or anything that sort of. So, we have within that the cloud, we have identity and access management, which means the users, the roles and policies are all defined. So those who are have proper privilege, they are the only one who can access the data. By default, we have turned off all the security rules and those things. So that way nobody can penetrate. You will have to enable all those roles and privileges before somebody can even access the cloud. Okay. We have this security built in here. We have transparent data encryption, what we call it, which means all the data are completely encrypted, which means even if somebody steals your data, they will not be able to make anything out of it, because it's encrypted at rest as well as in transit. Okay. This is because security is, we have depth in defense. So we have security built in at each level. So at edge services, we have DDoS protection, WAF protection. We are also monitoring all these activities. So there are logging happens whenever somebody tries to access a resource in the database or a resource in the Oracle Cloud, that is being logged and tracked. So you can see at any point of time, if you want to see who logged into my environment, what kind of data being accessed, all those things are being logged into our OCI.
Santosh?
Yes.
I have a question here that might be helpful to answer.
Sure.
Amnal wants to know, what is an LB, Oracle Cloud Infrastructure Innovation, at its core slide? What is the LB on that slide?
Oh, that is a load balancer.
Ah.
Yeah, because what we provide is the load balancer for 2 reasons: to distribute the workload, and again for the security point of view also, because all the SSL gets come to the load balancer, and from that point onward all the data get distributed to backend servers.
Good question, Amnal. Does that answer your question? Probably does. Okay, Santosh, thank you.
Okay. Also, we have like all those certification also, like HIPAA, PII, all those FedRAMP, all those things, certification we have in the cloud. We have SOC compliant, we have ISO 9001, level 2 cloud security alliances. So just to ensure that, yes, once you put in the database, all these certifications are there in case, your CISO or somebody wants to check that. Basically performance, we talked about this. Okay, just quickly I will go into the product. So in the compute for the within the Oracle Cloud, for the compute we have bare metal, VMs, containers, and functions. Also, when you use the processor, we have a lot of options to choose from. You can either choose AMD, EPIC, or Intel Xeon, or now we have an ARM-based processor also you can choose. So whenever you provision a VM, you first try to choose the shape. Shape is nothing but your CPU and the memory. And for that, we have these processors available into the cloud. Also, you can choose the various flavors of the operating system there. We have a local attached storage as well as remote attached storage. And it's all, flash-based storage. Okay. Storage, we have a local, we have a block storage, file storage, and object storage. These are 4 types of storage available. We have a HPC file system, and then archive storage. We also have a storage gateway and data transfer. So like if you have terabyte or petabyte of data are there, it is hard to just transfer like that. So we have a data transfer service also, which basically makes sure that your data goes safely onto the target system, and there is no cost to that also. In terms of the network, we have, I talked about a virtual cloud network. For connectivity from your on-premise to the Oracle Cloud, we have 2 flavors there. One is your regular VPN, or second is Fast Connect. Fast Connect is the dedicated line from your on-premise to the Oracle Cloud. Also, one other advantage of having Fast Connect, we don't have an ingress or egress cost for that, so it becomes very simple. Load balancing, that is where LB came. Load balancing, you can have a choice of TCP, HTTP. You can auto scale that load balancing, and then end-to-end SSL and TLS encryption. We have a service gateway. Just to so for example, if you want to take a backup of your database, for example, instead of going through the internet, it has a service gateway which has a private access where you can take the backup, which goes into the object storage, so it does not get exposed to the public internet. We have a DNS service also, which will give you a resolution to your host. This is just one pictorial where on the left side you see the data center, on the right side you have cloud region. So it's nothing but the extension of your data center. You can connect it using VPN or Fast Connect. I talked about availability domain, which is nothing but the physical data center within that cloud region. We have load balancer here, as you can see, DNS. And then end customers can connect it in that way. HPC,
Santosh,
we have.
Santosh, we have a quick question. Who is your ARM processor provider in the Oracle Cloud? That's from Matthew.
Oh, it's Ampere is the one. Just let me go back. Ampere.
Okay. Yeah. Thank you.
HPC, low cost, flexible CPU, GPU, bare metal, and also we have something called universal credit system, which means you only pay for what you use, and all the services are available to you. It's not that you every time you need a new service, you will have to again request for that service. So all available in the cloud. You pay only for what you use. We have a high performance bare metal system. And then we have this GPU servers and the Exadata machine also. Yeah. Okay. This is some of the performance number I have put it here. Exadata Cloud Service is our engineered system in the cloud. Basically, this is a very high performing database machine, basically. Elastic expansion, you can scale up or scale down the CPU, the storage. Sorry, and these are some of the governance and management in the cloud, access control, monitoring, auditing, and as well as the notification are available in the cloud. So as I talked about, the lots of developer service available, which help the developer to build the application pretty fast. We have the Kubernetes functions, app service, all those tools are available also. Plug-in, play, low code, Apex applications are available. Okay, this is all container engine for Kubernetes, OCI registries. Also, this will be my last slide. I might have moved very fast, but one opportunity here for all the students, you can have your own tenancy without any charges. So if you log into oracle.com/cloud/free, you can create your own tenancy which never expires. So you can play around with the Oracle Cloud using that tenancy, and it is for you. It never expires. So I think that's all I have, Mary. I had,
Okay.
I think 4:30 now, according to me, it's 2:30, right?
It's about, yeah, that's about right. Any questions for Santosh at the moment? Well, that was very interesting, and I think it would be interesting to look at your educational funds for maybe setting up a tenancy for HPC students to access Oracle and work on HPC resources. So we should talk about that. That would be interesting. John Gee was a student on the student cluster competition team last fall, and he was one of our leads on the Oracle Cloud. So John, are you here and ready to? Okay. Do you need to share, or are you just going to talk?
I can share screen. I just have a few screenshots gathered.
Just about 3 or 4 minutes, please. Cindy, can you set him permission to share? Okay. Go ahead and share, John, I think.
Yeah, sorry, Mary, I moved pretty fast. So your students, if they will have any question, they can always email me and I can answer that way too.
You see the
Thank you.
Yeah.
The screenshot?
We'll put your talk into our GitHub repository. Okay, John, go ahead.
Can you guys see the screenshot?
Yes. Yeah, we can.
All right. This is like the cluster, the competition committee provided us for the SC21. So each of the team owns a small cluster that we can log into, and it's attached to some central server that we can upload and download files to. And for each of our cluster, we have, they provided us one login node and 4 bare metal compute nodes with some optimized like 36 cores, and a GPU node with I think 8 NVIDIA 8100s, and then a lot of storage. On the compute node as a local disk and some NFS. And here's a screenshot of one of the application we had to run. Was called Rambo, and this is we were running it on all 4 of the HPC CPU nodes basically, and then this is on one of the nodes when we're running it. And here's a screenshot of the 8 A100s when it was running Cardioid, which is the application I was in charge of, and it was all running 100%. And you can see the RAM and power here. And the last thing was we had to figure out a Oracle technology called RDMA, where they interconnect the compute nodes, and then we had to figure out how to use their technology instead of the normal Ethernet connection to minimize the latency. And then actually it's very fast. We only has like less than 2 microseconds latency between these nodes. Yeah, this is all I prepared.
Thank you very much, John. That was great. Does anybody have any questions for John?
I have one question.
Sure.
How did it go, John?
Oh, it was pretty good. We did overall number 4 and number 1 in all the US schools.
Wow, that's very good. And of course, this is very little time here, but if you have thought about any improvement for your next competition next year, just let us know, so that way we can incorporate that. If there are any weakness into the design or this architecture.
Yeah, we'll let you know.
That's a great idea. Thank you. Okay, so thank you very much, John, for showing up and sharing your experiences with the student cluster competition. Our next speaker is Paul Yu. He's with the Azure team, Microsoft Azure team. He's one of our ongoing mentors for student activities. So without further ado, Paul, I'll let you step up to the plate. And if you want to give yourself an introduction, go ahead and do that. Thanks.
Sure. Hi, everybody. Paul Yu, work at Microsoft as a Azure Cloud Solution Architect. And let me share my screen. There we go. Let me know if you can see that.
Yes, we can.
Cool. Yeah, as Mary mentioned, I've been mentoring this group. I think this is like the 3rd year now. So time flies. Yeah, so I work as a Azure Cloud Solution Architect. I'm actually based up in the Los Angeles area. I've been working with education customers for a number of years now and support pretty much a lot of the higher ed institutions up and down the West Coast, right? I'm here to just basically talk about Azure, give you a little bit of an intro into Azure. I think the majority of the folks on this call might be new to Azure, potentially gearing up for this year's cluster competition. And so I've done this talk a few times now, and they may have been recorded previously. So it'll just be, hopefully, you learn a little bit of something about Microsoft Azure, okay? So what is Azure? Oops, I didn't want to go all the way to the end. Hang on a second. There we go. So what is Azure? Well, Azure is Microsoft's cloud computing platform. I joined on the tail end of the previous speaker, speaking around Oracle Cloud. And so a lot of different vendors, they all have different clouds, right? So Oracle has one, AWS or Amazon has one, and then Microsoft obviously has one as well. So Azure is a cloud computing platform that offers you number of capabilities, right? At the core of it all, we have infrastructure. So it's just kind of like foundational infrastructure capabilities, which includes compute, networking, storage, and then of course, security and identity, which is a big part of our overall cloud security story. This is all core infrastructure, and typically for this particular competition or HPC in general, you would be working in this area, right? As we start to go up the stack here, we do offer some serverless capabilities. Serverless doesn't really mean there are no servers. It just means that there are servers that you don't have to particularly worry about, right? Because when we're talking about core infrastructure capabilities, the compute, the networking, things like that, typically you're on the hook for managing, maintaining, patching, securing a lot of that stuff, right? The cloud provider will take care of, a certain number of those tasks up until a certain point, and then everything else is on your area of responsibility, right? So that's why customers are they like to work out of like typically like the serverless realm, because you just have to worry about bringing your application to the Azure cloud, right? And then if we go up the stack a little bit more, we also have support for like edge devices. This is like where we get into like the IoT realm, right? So you can deploy application code out to these edge devices. And then interestingly, you can also bring Azure hardware into your own data center, right? So if you have really strict security requirements and you need to be in a data center that's located on premises, then you can do that as well, okay? At the heart of it all, Microsoft has been around for a long time, but Microsoft has always been really, really strong in the developer tooling area, right? So we offer things like Visual Studio, GitHub, and then of course, Power Apps and Power BI, which is leaning more towards the citizen developer space, okay? Now, when it comes to Microsoft, you know, obviously we have our a great deal of tooling, but because you're in Microsoft's cloud, it doesn't mean you have to stick with Microsoft products, right? Azure works very well with the open source community. And if we're looking from the bottom up again, when it comes to like application frameworks, applications that you can actually deploy into Azure, of course, we support Microsoft.NET, but we also support open source tooling like Node.js, Python, Java, PHP, and Ruby, right? When it comes to infrastructure, of course, we're going to support Windows workloads like Windows Server and things like that, but then we also support a variety of Linux distributions that includes Red Hat, Ubuntu, you know, what have you, okay? Fun fact about Microsoft Azure is that I think, I can't remember what that number is, but definitely more than half of all of the compute workload in Azure, interestingly, is not Windows, it's Linux. So it's just the way, or it's just the way the market or the industry is going, headed towards these days. A lot of open source technology, and so we're seeing that within our own data centers. We have more Linux workloads running in Azure than we do Windows. I'm not going to sit on this slide for too much longer, but basically, any of the open source application stacks when it comes to web development, database, you know, we support Mongo DB databases on our Cosmos DB service. If you're doing anything like Hadoop or any of the big data analytics, we support that as well. And then when it comes to management, things like Chef, Ansible, Terraform, right? So that's all supported. When it comes to Microsoft Azure, about 95 or over 95% of the Fortune 500 companies are actually deployed onto Azure. I really wish this slide included a lot more EDU or higher education customers, because there are a pretty significant number of higher education customers that use Microsoft Azure as well. And so I feel like being able to work in the Azure platform is gonna go a long way, especially as you move on and you know you work for companies, maybe one of these companies, right, that are already in Azure. So, so why do these Fortune 500 companies, you know, work with Microsoft Azure? Well, it's because Microsoft, you know, at Microsoft we have this mantra of, you know, Microsoft is built on trust, right? And so security is a huge foundational component of our overall story, right? Not just Azure, it's just Microsoft products in general, right? When it comes to security, there's like two sides of that coin in the way we approach it. Number one is going to be having a secure foundation, right? That includes all of our data centers. We have over 100 data centers across the globe, and each of those data centers are tightly locked down. I mean, like from physical access to network security to what have you, you know, background checks for the personnel, things like that. And then there's also the operational security, right? So once your workload is in Azure, Microsoft is actually looking after all those workloads, right? We're probably one of the most attacked companies in the world, right? And so we actually employ a great deal of security analysts that will actually monitor and secure your workloads at real time, right? So we have, I think this number has gone up since this slide was produced, but we have well over 3,500 full-time security professionals that are actually monitoring, I mean, trillions of signals per day. It's huge. And then Microsoft has, we have a pretty significant investment in security, right? So we invest 1 billion annually. And so we need to protect all these workloads, right? So we see all these blue dots in the map here, and I'll show you a better map in a bit, but we have a lot of data centers, we have a lot of customers running on Microsoft Azure, and so we take that very, very seriously. When it comes to security as part of that, along comes regulatory compliances, right? So you all are working in the HPC space, generally around research. Once you get into research that's like federally funded research, where you are working with U.S. government grant dollars, right? A lot of times there's stipulations on those grants where they require you to do your work in a computing environment that meets certain regulatory compliances, right? And so it could be things like HIPAA, CIS, NIST, right? These are all things that as a researcher or as a computational scientist that you don't really have time to worry about, right? And so Microsoft offers a lot of these compliance offerings, and so it kind of gives organizations, researchers that peace of mind that that the cloud itself, Microsoft Cloud, has been certified for all these compliance offerings. And then we also have best practices in how to further secure that within your own deployment, right? Because shared responsibility model. So when it comes to Microsoft networking, right? We have data centers spread across the globe. And cool thing about this is that the unique thing about Microsoft Azure is that as data traverses between regions, between data centers around the globe, all that network traffic traverses over the Microsoft network. It never hits the public internet, right? Microsoft actually made investments in this area, and Microsoft has laid down over 2 million miles of fiber, right? And so we have these deep undersea cables that kind of connect all the data centers together. So that's pretty cool. I'll show you this map, but I want to show you a better map. So when it comes to deploying your resources, as you're in the, working in the Azure portal, and let's just say you want to deploy a virtual machine, maybe a GPU-based virtual machine, it's going to ask you what region you want to deploy into. And so these are generally the regions that you're in. And regions are important because you want to make sure you have the least amount of latency between where your data is and where your compute is. And so this is kind of gives you a high level of view of where these regions are. And I will show you a better map of this. So if you head out to infrastructuremap.microsoft.com, we have this pretty cool spinning globe thing, and it kind of lays out all the different regions that we're in. And so over here, West US, if you click on the bigger blue dots here, it kind of shows you or tells you where this region is. And so this is up in the Bay Area. West US 2 is up in the Washington area. And then this brand new region that just opened up is West US 3, and that's in the Phoenix area. So you're probably going to be deploying into one of these regions over here, okay? And so, like I said, you can spin the globe around, And you know, you can see the fiber that's been laid down as well. So take a look at that. Now, that's kind of Azure at a very, very high level. One thing I do want to call out before we jump into the more HPC specific things is, I don't know if you all have started with this yet, but we do offer Azure for students, right? And so you being a student, you having a .edu email address, you are eligible to come to this website over here, and I'll share the link at the end. Actually, I'll just drop the link over here in the chat window if I can find it in time. Okay, I found it. Azure for Students. So come here, click on the Start Free button, and you can just get started. No credit card required. That's the unique thing about this Azure for Students offer, is that, you know, any other offer will ask you for a credit card, but in this case, we won't. You just sign up with your .edu email address and you'll get right into the Azure portal. You do get $100 to play with, and this $100 is renewed annually. So every single year that you are in school and you have that .edu email address, we'll just ask you to renew your credentials, and we'll give you another $100, right? And so in addition to that, you also get access to free services, right? And so this is kind of like the landing area. So once you sign up for the offer, you'll see here like, hey, here's your $100 and expires on this date, and here's how much you used so far, right? There are things that you just get for free. So you see here, you get 12 months of Linux virtual machine. Oop, I didn't mean to do that. Where did it go? Free services. Oh, let me click back. Okay. You do get certain compute for free, right? So this doesn't decrement from your $100 offer. So take advantage of it. Unfortunately, and we've ran into this in previous HPC training sessions over here with the SDSC, is that the SKUs that you're interested in for HPC workloads, they're typically not included. They're not included out the gate. You may have to request it, but then, you know, you're going to eat up your $100 real quick. So this offering is good just to kind of get familiar with the Azure portal and kind of navigate around, right? So, but for any real HPC workloads, you'll probably need a different type of Azure subscription for that, okay? All right, so let me jump back over to my slides real quick. Just some really, really high level fundamentals when it comes to Azure. So everything is backed by identity. Azure Active Directory is the identity store. If you're a UCSD student, you're probably already in Azure Active Directory. That's what's going to get you into Azure for Students, right? So that's the identity store. You should already have that. When you create your subscription, that's what you're going to get. So the subscription is tied to the identity, and that's how you can get in and do your work. When you deploy an Azure resource, all of your deployments are in this logical container called the resource group. That's just where you put your stuff in. And it helps you manage your deployments as a single unit as opposed to a bunch of different things, right? Because when you spin up a virtual machine, that includes the actual virtual machine and the network interface card and the data disk and all that stuff. And it's just really easy to just manage all that together as a logical resource group, okay? Identity and access management, typically not, I'd say it's very important, but it's not something that you do all the time, right? If you have your own subscription, your identity and your access management is already set up. Once you start to work as a team and you want to invite other folks into your subscription to collaborate, this is where you're going to need to get a fairly decent handle on how to grant access to others using what we call RBAC, or role-based access control. And so you can get pretty granular on how that access is granted, right? So you can say, yeah, I want, let's just say Charles, I want Charles to be able to work on my virtual machine only, or I want Charles to work on everything in my subscription, right? So you can do stuff like that, okay? Virtual networks, pretty important concept here, because when you spin up a virtual machine or a virtual machine scale set in Azure, it always has to be tied to a virtual network, okay? When it comes to like your HPC or your test environments, don't worry about the IP addressing. Azure's going to take care of all that for you. The Azure portal, that is, going to take care of all that for you. Once you start to get into the realm of, hey, I need to now connect to services that are in my campus network, that's when you're going to have to start worrying about networking. But for the most part, just know that it's here. Azure will take care of it for you. We'll default your address space. And as long as you don't need to connect to other virtual networks, you should be in a nice, safe, isolated spot, okay? How can you work with resources in Azure? Of course, there is the Azure portal, right? So there's this, and this is the place where you are going to actually start off. But as you get into, I guess, more complex or more repeatable deployments, that's when you need to start looking at other tooling like Azure Resource Manager templates. It's just a collection of JSON files that you submit. And then, of course, there's the command line. I personally love command line. And so I do a lot of my deployments using the Azure CLI, or Azure PowerShell. But I'm pretty much spend a lot of time in CLI, okay? When it comes to Azure Cloud Shell, that's available for you just by toggling this button up at the top. So you click that and it will create basically a shell that's hosted in the Azure cloud. And it offers you a terminal in which you can interface with the Azure APIs, okay? And then, of course, there's Terraform, which is really popular. And then, of course, Ansible, okay? When it comes to deployments, right, I talked about the core services that we offer, compute, networking, storage. This is what we consider or we classify as IaaS, or infrastructure as a service, right? And then we get to the higher levels, which is like in the serverless realm, like if you recall my chart. And so we call this platform as a service. And what you're going to start to see here is that as the level of service goes a little bit up, I guess up the ladder, as I would call it, you are on the hook. You're not as responsible for a lot of the stuff that goes on, right? So maybe this picture will explain it best. So when it comes to infrastructure as a service, right? Microsoft will manage all of the underlying like physical compute, networking, and storage, right? Because they're in our data centers, we rack the machines, we connected them all together, right? What you are responsible for is the virtual machine, the operating system, the runtime, the applications, right? So you're responsible for everything in green here, okay? As you start moving up the ladder to platform as a service, Microsoft will start taking more of that responsibility. So we'll take care of the virtual machine, the operating system, runtime. You only bring your app and your data. And then if you go all the way up to software as a service, which you're not going to be doing for HPC work, but for software as a service, you are only responsible for the data and access. So that's kind of the way it works, right? Share responsibility. Azure provides this nice computing platform, which has all these nice regulatory compliance certifications attached with it. But as a consumer of the cloud, it is still your responsibility to ensure that you are deploying in a safe and secure manner. That includes things like, as much as possible, avoid putting public IPs on your machines, making sure you lock down your networking, and just making sure that you have the right people in your subscription that you trust, right? So pretty important. Okay, I'm gonna have to speed through these. Azure platform for HPC, okay? So going down the stack here, we offer definitely optimized compute, right? So as you start looking at our virtual machine compute SKUs, you'll start to notice that we have a naming convention, right? And so we have this H series and then we have the N series. The H series are generally for your HPC. That's how I equate them, HPC. These are the SKUs that you would typically be working with in your clusters. And then the N series, which are GPU based, right? And so let me just flip it over here, right? So H series are high memory bandwidth, supports InfiniBand, and then we have your N series, which has support for GPUs, okay? We also have these SKUs down here, but generally they're more for like general purpose type stuff, okay? Just a quick note on GPUs and the type of GPUs that we support, right? The NCs versus the NVs. Generally, NVs are used for visualization. The NCs are for computing, and then the NDs are for like deep learning tasks, okay? We also offer Cray, which is supercomputers in Azure. And then this is probably the area that you're going to be working out of, is going to be workload orchestration in Azure, more specifically working with CycleCloud, okay? CycleCloud is a orchestration engine that enables you to deploy virtual machine scale sets without having to worry about the virtual machines, essentially, okay? And so in a traditional cluster, typically, the way that works is you have a pre-allocated cluster and you're using some sort of scheduler to submit your jobs into. Azure CycleCloud acts as an intermediary and provisions virtual machines on your behalf, and it works with all sorts of clusters. Azure Batch, don't worry about Azure Batch for now. I don't think you'll be using that for any of your competitions, but just know that Azure Batch is a service that allows you to do pretty much the same things that CycleCloud will do, but just it's in that non-traditional schedule formats, right? So this is Azure native capabilities, okay? This is a really old screenshot. CycleCloud has changed a whole lot since this, but in a nutshell, it's basically allows you to deploy workloads into Azure. And the cool thing is there is this hybrid capability where you can have an on-premises cluster and you can use CycleCloud to deploy to pretty much extend your on-premises cluster into Azure, okay? And it works with all the common job schedulers, so Slurm, Grid Engine, things like that. Okay, and I think I am at time, and that's pretty much all I had. Feel free to send any questions along the way. Mary knows where to find me, and typically I would be around a little bit longer just to kind of, we'll do walkthroughs. So yeah, if you have any other questions, let me know, and I'd like to thank you for your time.
Thank you, Paul. Are there any questions for Paul?
I'd like to ask a question, actually. Paul, do you know if Microsoft will be deploying any new HPC hardware this year? Something along the lines of AMD's Zen or EPYC Gen 4, or did they not tell you these things?
They generally don't tell me these things personally, but the way I always find out new stuff about Azure is by going to, I think it's updates.azure.com. this is where the product team, right, the team that actually works and builds this stuff, this is where they will post all their announcements. So if there's a new SKU coming out, they will generally update you there. And then they have like this whole RSS feed where you can subscribe to kind of learn all that stuff.
Great question, Matthew. So Matthew will speak next. Thanks for your time, Paul. We'll be planning a student cluster competition 22 team. I'll talk about that when Matthew is done.
Good stuff. Thanks all.
Yeah, we're pretty excited. Thank you so much. We really appreciate your time.
You're welcome. Bye-bye.
Okay, bye. Matthew, Matthew was on our student cluster competition team last fall, as John was, and he's going to talk about his experiences with Azure. Go ahead, Matthew.
Yep.
And then Marty,
let me.
Yeah, he should be a co-host at this point.
Not
Cindy
yet.
can fix that.
Yes, please fix that, and I will gladly present.
You are a
It's been
co-host
fixed.
now.
Okay, perfect. Thank you. Hello, everyone. I will be presenting about Azure and using Azure for the competition. I just have a couple short slides. Okay, can you see my screen?
Yes.
Fantastic. Okay, so yes, as Mary mentioned, we used Azure for the student cluster competition. In the student cluster competition, we actually had 2 cloud providers. One was Oracle, one was Azure, and we used Azure for the majority of our events. Although 2 very important, 2 or 3, I don't remember if it was if the mystery application was which one was on Azure or on Oracle, but so 2 very important applications were on Oracle, but the majority of them were on Azure. And so our Azure was slightly different than Oracle. So, what did we do with Azure? As Paul mentioned, Azure really has everything and the kitchen sink. They're really going for competing with AWS in terms of providing every possible imaginable cloud service, but we mostly just use what's called Azure Cycle Cloud. And so Azure Cycle Cloud is essentially this infrastructure as a service. So to set it up, you go here, you click Azure Cycle Cloud, and essentially you get this homepage. And what it is it's kind of right in between infrastructure as a service and bare metal as a service. So we don't get direct access to the hardware to actually boot our own OS, but you are allowed, when you're configuring the cluster, you can actually like upload your own image and then use that image in the competition. And so essentially during competition, they gave us access to this Azure Cycle Cloud homepage, and then we were able to configure our own clusters. And for each cluster, you get to choose the hardware that you want to use for that given event. And so as you might expect, for different applications and for different benchmarks, you actually want to use different hardware that gives you the best performance per dollar or sheer performance for that application, depending on what you're going for. Every year we sort of look at what Azure has to offer. And for the previous 2 years, the best they've had to offer is essentially AMD EPYC CPUs and NVIDIA V100 or A100 GPUs. So the EPYC CPU is essentially a high performance and data center oriented CPU. They have 2 generations, Gen 2 and Gen 3. Unfortunately, last year we were not able to use, actually, I don't think we were able to use EPYC Gen 3. We're only Gen 2, and we were hoping to use NVIDIA A100s, but they didn't have access to that either. Now, one of the things with the cloud, and especially with the supercomputing competition and the virtual supercomputing competition, is that it is essentially a competition for DevOps. Very many of the skills are oriented to setting up and managing clusters and just infrastructure in the cloud, and also deploying applications, scaling applications, and so on. As you might expect, as you might have heard, DevOps engineers get paid a lot of money because some of the stuff is rather annoying. Some of the stuff in the cloud, it's really hard to debug. You have to, try quite a few things, go through documentation of a million different software packages. And that's why it's really useful for us to have someone like Paul that we can just email a lot of the time, and he can get back to us with an answer. But yeah, during the competition, you really spend a lot of time pouring through documentation pages, trying to understand how a certain feature works or why we can't upload an image or something along those lines. But it's very, very good learning. And so, you might ask, well, what do we actually do? First, one of the things we do is we have to upload our image over here and actually, so choose an operating system, choose some of the code that we want built into our image, choose our file system. So you can see here that there's this BGFS option, and this is a parallel file system. And using a parallel file system allows you to pretty significantly increase your storage access speeds. And so we want that. And then if you've successfully uploaded an image of your own, you can use that. And then we have to choose our hardware. And so for choosing our hardware, typically we would pour over these different, spreadsheets that they have on the Azure website, and they go over, the number of cores, the cost. Generally, also something really important to keep track of is the availability for the competition. And then we would do sort of back of the envelope calculations for performance per dollar for every application. And so for some things, and eventually we actually did points per dollar. Is the end goal in the virtual supercomputing competition is to optimize for points per dollar and get the best scores in that. And so actually something you can see here, one of the benefits of Azure is that every year they have this Grafana dashboard that's linked into the Azure Cycle Cloud, essentially application that they give us. And so what that means is that the competition dynamically keeps track of Azure usage, resource usage. And so we have this dashboard every year that goes up that tells us exactly how much money every team has spent. That's under this cloud burn rate. I don't see if you can see it, like a little graph over here. And then also, the overall cloud spend. So how much money have they spent and how fast are they spending it? And it also tells us how many cores they're using. And so something that's interesting every year is to see, based on this chart, how are teams building their strategy. So usually we can guess that if they're not using very many cores, but they are burning insane amounts of money, as you can see, for instance, over here, Peking University spikes in this like red rectangle. Then if you check the chart carefully, you can see that Peking University isn't really using all that many cores, but they're using a ton of money. And generally speaking, that means that they are using GPUs, because GPUs are very expensive. And they don't have very many CPU cores attached to them, but they're very, very fast. And so the competition is pretty exciting. This part of the competition is really fun, but essentially there's a lot of also strategy that goes into deciding how to spend the Azure resources we're given as efficiently as possible in order to get the best score. And that comes out to entirely different strategies for different things. So I worked on the computational chemistry event, and in that event, one of the subsections was focused on getting the lowest cost per run for finishing a certain simulation. And if you think about it, what is cost per run? Well, it's essentially it's essentially best performance per dollar, because you need the performance because you need your application to actually complete, but it's per dollar because you want the product of the time spent running that CPU times the total cost per time of running that CPU to be minimum. And so for that, as I found out, basically the best you could do was one AMD CPU, not a core, but a full like chip. Whereas the best you could do for sheer performance was as many GPUs as you can possibly buy. And so what's interesting is, and you want the sheer performance when you're doing your benchmarking for HPL or HPCG. And so what you can see based on the cloud burn rate chart is that some of like the most competitive teams from last year, like Shanghai Tech and Tsinghua, essentially used very, very little compute in very calculated methods. So if you, for instance, track like the Shanghai Tech line or even the Tsinghua University line, then at exactly like 8 p.m. or something, they'll turn on exactly so many cores, run it for exactly as long as they need to do all their simulations and solve all their problems, turn it off, and save as much money as they possibly can until the end, when they use the remainder of all of the money they have left to buy and reserve as many GPUs as they possibly can, and then go for the highest sheer performance in HPL or HPCG, which are our sheer performance benchmarks. And so
Matthew,
yeah.
Hey, Matthew, sorry, we're running behind, so I need you to wrap it up so Marty can teach people about JetStream.
Yeah, okay, my bad. So
okay,
yeah,
thank you. No, it's
Azure
okay.
is quite fun. Azure is quite fun. There's a lot. It's a pain in the butt, but it's very exciting to learn about. And that's all. Thanks, folks.
Thanks so much, Matthew. All right, our next speaker is going to be Marty Kandes. He's in the user services group and is a computational data scientist at SDSC, and he's going to teach you how to use a cloud that you have access to as a result of being in the HPC user training. Marty, are you ready?
Yeah, I'm here. Let me just
Okay.
get
All right.
my screen share. Where is the?
Yeah,
There it
while
is.
Marty is getting set up, I'm going to put a link into the chat for students interested in the student cluster competition activity. We're taking applications now. So I think you've gotten an email on that, but go to that link, and students who are undergraduates at UCSD are welcome to join the team and play in that arena. Thanks.
Okay. Thanks everybody for joining us today. I know we've already had a few speakers, and essentially, we're all sort of talking about, what sort of cloud computing looks like as a user. And you'll see here with OpenStack, it's in JetStream, all the same fundamental concepts you learn when you're first starting out in cloud computing. You're going to run across a lot of the same terminology, same concepts, same sort of structure to how all these sort of clouds operate, essentially to manage the underlying compute network and storage infrastructure that you can interact with. The one thing about OpenStack is it's an open source version to do this, to manage sort of your own private cloud. And obviously there's not as many of these higher level sort of platform and software as a service kind of services available. It's more on the infrastructure as a service side. So yeah, I just want to give you a quick rundown of OpenStack and JetStream, which is an OpenStack cluster you have access to. And if you're new to cloud computing, it's probably an easy way to get familiar with some of these concepts of instances, volumes, and all sorts of things that you can attach to your cloud resources as you for whatever sort of task you're trying to solve. So it's a very short talk. I'm just going to give you a very high level overview of OpenStack and JetStream, and maybe run a demo if we have time and if people are interested. So this is the schedule for today, sort of what is OpenStack, what is JetStream, and I'll explain what JetStream 2 is, and then do a quick demo. So again, OpenStack is essentially a cloud operating system for hardware you might have, right? So it's a full, complete software stack that allows you to set up services to manage the compute layer, the networking layer, and the storage layer in a sort of private cloud if you want to run one yourself. And there's a very rich ecosystem of services, right? You can probably spend your whole career learning how to run each of these different services in an OpenStack cluster. I've never set something up like this myself, but it'd probably be like a fun project if someone wanted to try something like this. But the nice thing is we have access to OpenStack clusters through Exceed, right? And so this is what JetStream is. So JetStream, unfortunately, we're in a transition phase, so I'll explain that. But JetStream is Exceed's OpenStack cluster. So just like you have access to Expanse, and you have compute time available on Expanse to run some of these example jobs from the different training sessions that we've done, you also have access to time on JetStream. And it's an, again, OpenStack cluster. There's actually, this is the infrastructure, what it sort of physically looks like schematically. There's essentially two identical clusters, one out of Indiana University, one at the Texas Advanced Computing Center in Austin. So you can see the stats here. There's about 300 nodes, about 7,500 cores, a bunch of RAM and disk, and this is they use OpenStack to manage those compute resources, and you are able to request them for whatever purpose you want. And just like you run jobs on Expanse, you have a certain amount of time ticks away depending on how many resources you're using. The same amount of the same sort of system works there. We have an allocated number of sort of compute cycles and storage cycles or total storage that you can access as part of the OpenStack cloud. Now, the one thing, if you're interested in using JetStream and sort of getting familiar with it, I would recommend doing it as soon as possible. As you can see at the top of the slide here, it's supposed to go away soon. I don't know exactly the dates. I don't think Nicole's here. I think she actually knows the dates. But essentially, JetStream is, I think, almost 8 years old now. So it's pretty old. And it's a little slow, you'll see when you first start playing around with it if you jump on. But JetStream 2 is coming, and it's supposed to come online anytime. And it's a much larger system, you can see here. The structure is expanded a bit with a few new partners, University of Hawaii and Cornell University are now here. But the primary OpenStack cluster will be based out of Indiana University still. So you, instead of having two identical clusters across, across half the country, they have the primary one located in Indiana with a bunch of regional ones that are sort of there just for sort of high availability failover sort of scenarios for certain users. In general, I think most people don't use JetStream necessarily for HPC computing and data analysis. It's really for a few different things. It's used for data storage and sort of data exploration, a lot of interactive computing. So it's sort of with we had the talk on Jupyter notebooks. It's also used by a lot of science gateways for Exceed and the NSF research community, where essentially if your project requires a server to be on all the time, right? Running like a web server or some sort of database for your project, you would probably host that on JetStream, right? Because you have this always on service that you can run a VM out of, configure it however you want for whatever your needs are, and use your allocated resource time there for running, say, your genomic sequence database and serving it to your research community or your lab, right? Which is something you don't really do on systems like Expanse, where you're running sort of simulations or number crunching on data that you might download from a database that's maybe served out of JetStream 2, right? And yeah, so that's kind of the two. So the two resources. So JetStream 2 is not online yet. I was like looking last night and I couldn't find any new information about, when it's going to be up or what the new process is to get access to it. In theory, our allocation from JetStream should just transfer over to JetStream 2 when it's online. So if you're interested in using JetStream 2 when it comes online, just check back on the documentation. There's a bunch of links at the end of the slides here that'll be available. When JetStream 2 comes online, they'll have a process that you might have to walk through. Right now, if you are curious about getting on JetStream, there's a few steps that there's one that you have to do, and the other two here I'm going to recommend is kind of where you would start, just because we don't have a lot of time to go into the details of how to set things up, but I'll just give you some pointers, and these are the 3 steps I would go through to get familiar with if you're interested in playing around on the OpenStack cloud here. So the first is you need to request a TAC portal account, right? So this is separate from your Exceed user portal account. So you'll go to the link here and follow the information here and fill out and submit your account creation. So once that's set up, you would, where did my talk go? You'll then be able to log into the backend OpenStack, say, GUI web page here, right? So just like you would log into Azure or Oracle through your web browser, through their GUI interface, you can go ahead and do that. There's a bunch of other things that you can set up, like if you're interested in using the command line interfaces and APIs from command line on your system. All the information of how to do that is in this section here in the JetStream wiki. But at the very least, if you want to get started on JetStream, it'll walk you through how to set up the basic configuration that you're going to need to have set up. And it'll walk you through it using the GUI itself, right? So that GUI login from your web browser. And mostly what it's going to ask you to do is to walk through and set up the networking you need to set up, generate SSH keys so that when your instances spin up, if you want to start an instance to do something on, you need to give it your SSH public key so you can log in from your laptop to your instances that spin up once you have something running on JetStream. So it's a nice quick tutorial of how to do this. It's essentially what we've done in the past for the HPC training series here. We've actually gone through this together and tried to set this all up. But it's very easy to follow. And if you have any questions, feel free to get in contact with me and email me. We have access to the same account, so I'll be able to see what you've already created, and we can go from there. But that's sort of step 2. So once you have your TAC login, you can then walk through this networking setup. And after you have your networking setup, this is another nice quick tutorial in the same section on the JetStream public wiki, where it basically just walks you through how to spin up your first instance with a slight customization where you have this sort of non-standard thing that you would, setting up a disk on your instance that's not necessarily the default size of the built-in one that comes with, say, a certain instance size. So it's a nice walkthrough of how to start up a VM, what the different fields are that you'll click and why you're clicking them for booting up the instance with this sort of custom root disk. It's a nice quick tutorial that'll get you familiar with what it looks like and what each of these panels are as you walk through the compute section of JetStream, essentially, to spin up an instance. And yeah, so those are the 3 steps that you have to do, or the first one you have to do. This next 2 are the ones I'm recommending if you want to get familiar with JetStream and get on. And one warning I'll give you is if you are going to jump onto JetStream and walk through these tutorials, the way it's set up with our allocation is essentially, even though you're logging in with your username, your TAC username, your TAC user password, we all have access to the same allocation or this shared project account. And so essentially that means that if I spin up an instance and leave it running there, or just save it and snapshot it, in theory, you could go log in and you'll see it there, and you could say delete it if you wanted to. So if you are going to work in this account, what I'm asking is, don't delete or modify anything that you didn't create yourself. And also try to label anything you create with your Exceed username, so we know what resources belong to who, and so people don't touch them. And eventually I'll go through and clear out, maybe by the start of session 2, I'll go through the account and clear out anything that was created. So you'll have until maybe session 2 begins to access the account and walk through some of these tutorials and explore as you want. There's a bunch of other services. There's containers. You can set up your own Kubernetes cluster in theory. There's all sorts of things you can do with JetStream. Those 2 tutorials are very simple, straightforward to get started if you've never worked in a cloud resource like this before. I think that's all I want to say. And yeah, by the time, like I said, I'll probably go through the accounts and clean things up when session 2 for the training series starts. But by then also, I imagine JetStream 1 here will be gone and JetStream 2 will be up and running. And so they'll probably just clear all this stuff out for me magically anyway. So that's probably what's going to happen. I don't think they're going to migrate any resources from JetStream 1 to JetStream 2, or any running VMs and things that you might have. So, okay, let me stop here and see in the chat if there's any questions, and then maybe I'll show you a quick demo. Okay. Let's see. Kyle is asking Matthew a question. Okay. Okay, so I'm all saying that JetStream 2 will enter production winter of 2022. Yeah, I mean, I think technically it's still winter, isn't it? So, I mean, yeah, it's supposed to be coming soon. It was supposed to be up and running, I think, in the fall, but it got delayed, I think, due to supply chain issues. So, yeah, again, like I said, it's coming very soon. So we're in a, you know, an awkward transition moment where JetStream is still available, but it's going to go away any day. JetStream 2 is going to come online. So don't invest too much in JetStream 1, other than, you know, if you haven't used a cloud resource like this before, you know, you have free time available. All it takes is getting your login, going around, poking around, at least through the web-based GUI. You know, it's as I said, the same concepts you'll see when running in AWS, Azure, and Oracle Cloud. A lot of the same concepts that you do to set up things on JetStream are easily translatable over to setting up the same things you'll have to do when you say start up an Azure account or an Oracle account. You'll have these things with the networking you have to set up, you know, get your keys all configured, and, you know, run in, booting up an instance, and all these different choices of what type of volumes do you want, how to size the disks with, you know, the virtual CPUs, you know, how many you want, and you'll see it's all kind of the same, at least at this fundamental sort of infrastructure as a service level. Okay. Okay, so just to end the talk, basically, I was just going to walk through a quick demo just to show you what this looks like once you, I'm not going to set up all the networking. I already have that set up for me, but, you know, to sort of tie things together, you know, I gave a talk a few weeks ago on how to use Singularity on Expanse and what Singularity containers are. One of the fundamental things that was, you know, I mentioned was a little difficult for new users to Singularity is to build your own containers from scratch. You need access to a Linux system where you have sudo or root access, right? And one place where you now do have access to root access or sudo is on JetStream. So this is what I use JetStream for all the time myself. I use it to build the containers that we deploy on Expanse and all of our systems at SDSC. So I'll just kind of show you what I do there. And yeah, that's kind of where we're going here. So let me go ahead and, you know, there'll be some additional references here at the end of the slides that you can look at. There's different tutorials as well about using JetStream APIs and even Terraform, as was mentioned on the other clouds. This is kind of the cloud agnostic way to sort of, you know, build your cloud resources on the command line and orchestrate them. But please go ahead and check those out if you get interested in using JetStream as well. Okay, so let me go to the login here. So I've already set up my login here. So again, you'll have your TAC credentials here, which are different from your Exceed logins. Go ahead and sign in. This is what the interface looks like essentially. Right, so here's your username. You have the different allocations that your account is associated with. And so you'll see this CCR allocation. That's going to be your allocate or our allocation for the HPC users training series. Right now I'm using one for another allocation I'm on just because everything's set up here. And so you only see one. You know, as I mentioned, there's a bunch of different things you can do on an OpenStack cluster, right? You have your compute instances. This is what we really want, is just how to spin up a VM, and with all the sort of things that go along with spinning up a VM. There's, you know, again, I mentioned things for like setting up Kubernetes clusters, there's orchestration, there's databases, there's object stores, many things you can do. but today we're just going to spin up an instance and try to build a Singularity container. Okay. So let me zoom out here a little bit. So I already have a instance running here, and for a purpose, I'll show you in a minute. But once you have your networking set up, which I've already done in this section, which is what you'll walk through in that step 2 tutorial in the slides, you can then go on and launch an instance, right? That's the step, essentially the step 3 tutorial in the slides. So you come up here to launch an instance. You want to, as I said, label anything you create with your username. So we know who belongs to, what resources belong to different people. Let me see. Okay. Just trying to make sure I didn't double name it here. So give your instance a name. Again, it'll walk you through these different sections to configure each instance. Here, this second panel is essentially to select what image your VM will boot with. If you read the tutorials in the public wiki, the default ones that JetStream provides you, which you can then build off and save your own versions of, start with JS-API essentially. And what I'm going to spin up here is an Ubuntu 20 instance or image. I'm not going to create a new volume on this one. I'm going to boot it from the image itself and essentially use the root disk that's available with the VM, with the instance that it comes with. So for this task, I chose the M1 small, but things go up here to 44 cores, 128 gigs of RAM, and the root disk only goes to 60 gigs, but you can always attach some ephemeral volumes here if you need more storage. But for this task, I'm just going to take a small instance. I have my network here set up for my Singularity build environment. And security groups is kind of like your firewalls on OpenStack. There's very similar, I think AWS at least calls them security groups too. I'm not sure about Azure and Oracle, but again, the fundamental concept of this security group, it's kind of like a firewall in some sense around your instances with different rules for what kind of ports are open and the ingress and outgress sort of data that can come from them. Again, you have to set up a SSH key pair so you can log into the instances. And you can do some other customizations on when your instance is spinning up. For example, you can tell, install these packages when the instance starts up so I don't have to go do it manually. And you can automate that kind of thing. Okay, so that instance is spinning up. I will log into this other one. I'll mention what this floating IP is here in a minute. So this IP address, you'll notice there's 2 associated with this instance that already had running. Ooh, I spin up the wrong one over here. I'll redo this in a second. You got the operating systems backwards for my demo here. So yeah, so you'll notice this original instance, this Ubuntu 20 instance was already running. And to log into it, I'm just gonna give it this IP address. And you'll notice again, there's this 10.1.1.14 address. That's the internal private IP address of the instance. But for me to log in remotely over the internet to the instance, it needs a public IP address. And so these floating IPs are what you associate with the instance to gain access from the outside, right? So my security group, that firewall I mentioned, it has permissions to allow SSH access through the firewall. And so I'm going to try to log into my instance here because it already has my key. Okay. So you can see here that I'm logged into this Kandes Singularity instance here, right? So this is my instance that's running on JetStream. And what I'm going to do here is go to my repo, which I mentioned during my Singularity talk, where I have a bunch of different definition files, these manifests that you can use to build, existing containers that we already have. And I'm going to git clone that. And the thing here is on this Ubuntu instance, Singularity is not installed by default. All right, so there's no command called Singularity. And unfortunately, I don't believe there is a Debian based or Ubuntu based installation for Singularity. And so, however, in my repo here, if you read the documentation, you can actually install Singularity with this helper command. So I'm going to kick that off. It's going to take some time. That's why I was going to spin up another instance, which already has Singularity installed. But if you want to use Ubuntu, that's one way you can install Singularity on Ubuntu instance on JetStream. Let me just redo this other one in Kandes Singularity. If you use the JetStream CentOS 7 image, this CentOS 7 latest, it actually already has Singularity installed. So you don't need to walk through the installation process even, is what I noticed when I was playing around with this. So you just spin up your instance again. This time I chose a different operating system image, so a different image to boot off of. Once that instance comes up, I'll attach a public IP address so I can log into the instance. Again, these mechanics are very similar on AWS and Azure. You'll have to select to attach a public IP address, and there's in those cases there's extra charges of money, I think, for how long you have an IP usually. Public IP addresses are, especially IP4 addresses are a diminishing supply. Okay, so I attached a public IP address here to this CentOS 7 image. I'll open up another terminal here. Oops. It's probably still booting. And you'll see it's already got Singularity 386 installed. So if you want to build a container that you say maybe want to bring back to Expanse and run, which is what I use JetStream for, what I do is I'll just clone my repo to the instance itself. I'll go into the repo, check out these definition files. Let's just build the base Ubuntu image. And let's do this one. It's probably smaller. So if you recall the Singularity talk, if you want to build a Singularity container, you need access to sudo access or root access to the system. Singularity is installed, and I just say build. This is the name of the image that's going to get built, the container itself, and then this is the definition file that actually. What? Oh, I know what's wrong here. Never mind. So my demo failed. I won't keep you guys until the other one builds. So there's something that needs to be fixed on this image I test. Anyway, so that's kind of the gist of the demo, even though, let's see if I can get this to fix really quickly. Let me see. Are there any questions while I try to fix this on the fly?
Yeah, Marty, there was one. Is it possible to go from your computer to mCandy Singularity to mCandy's Singularity 2, in essence, have only one public IPv4 address?
Yeah, I can show you that in a second here. Let me just kick this off. No. Yes. So, for example, if I go to, just open up another those, right? So what you'll need essentially is SSH forwarding ready to go, right? So, if you do SSH -A, let's see, log into the Ubuntu instance, right? Because both instances have my public SSH key in the respective user default user directories, right? There's the default Ubuntu user on the Ubuntu instance. There's the default CentOS user on the CentOS image, and both have my key, right? And so here I've logged in with SSH forwarding, key forwarding to the Ubuntu instance. So if I just go SSH CentOS at the private IP, that should work as well, right? Even if I took away the public floating IP. So that, yes, so that is one way to save on sort of these additional public IP addresses, like in the public cloud, right? So you might just have a login node that has a public IP that's more secure, that's more well locked down than, say, your cluster nodes behind it that are only running on a private network, right? So that's probably, like, as the students were talking about cycle cloud, that's usually probably how those clusters are sort of configured to spin up, right? They'll probably spin up a single login node where you access the cluster, but all the compute nodes behind the cluster are probably on private IP addresses, right? Because once you're in the login node, you can then access the cluster, right? Many HPC systems are set up this way too, right? Expanse and SDSC, how we've run our clusters, are usually very different, or are kind of unique in the sense where we have public IP addresses on all of our nodes, because there are use cases where that makes things much easier. But most HPC sites, I would say, don't actually. So anyway, so yes, that is a good question, and yes, you can, right? And I'm even have port for. I mean, I have my SSH key ready to forward. I can even log into Expanse, right? If I just type in. Right, I can log into Expanse from my instance here, or transfer my container over once I'm done building it, right? So let me try this build again. So one thing I forgot, which is I'm building a Ubuntu image on a CentOS machine, so I needed this extra package to build. Is that not? Oh, I'm in the wrong directory. Where am I? definition of files, Ubuntu. And so now it should build. Okay, let me see if there's another question here. No, that's the same question. Okay. Anyway, so that's kind of the demo of JetStream. You have access to it. You can, build containers if you want. You can just, walk through some of the tutorials that are available with JetStream. Learning sort of Terraform would be kind of cool because then you could use it on all of the clouds. There is that tutorial in the end of the slides associated with JetStream, so you could use them on, how to spin up an instance with Terraform on all 3 clouds. It should, in theory, work with the same code, roughly. And if there's any questions, we can stick around and chat.
Yeah, it's great. Quite a few people have stuck around. So thanks, guys, for doing that.
I guess if there are no questions, thank you. Thank you for being with us. And Mary, would you like to final up and close up for today?
Yeah, sure. So like Cindy said, there's session 2. Make sure you're registered. And then there's also the applying for the student cluster competition team. If you're interested in playing in that space for the summer, fall time period, feel free to register. And then thank everybody who presented on cloud computing, and hope this was informative to you guys, at least give you an overview of what that cloud computing is like. And thank you, Marty, for presenting JetStream. And with that, I think we're done.